In this video, we're going to take a look at the different problem types that appear on your Test 2 review in Math 101. The first problems we'll take a look at are equations, and the first equation we'll take a look at is equation 13. And so I'm solving this equation, so what I want to try to do is isolate x. And so I want to go through my kind of four-step process here. And the first step in that process is to simplify, and we can simplify over here on the right side. Lots of stuff that can be done over there. So that's where I'm going to start. And we would start on that right side by distributing the 8. So I'm going to distribute the 8 to both of those terms. So let's rewrite the problem here. 16x minus 18, 6. Now I'm distributing the 8. Positive 8 times positive 2x would give me positive 16x. Positive 8 times negative 3 would give me negative 24. Okay. Still working on that right side. It looks like we have some like terms to combine there, so I'm going to combine that 6 and negative 24. But I'm going to rewrite everything else while I'm doing this. So I'll have 16x, and when I combine the positive 6 and the negative 24, that is going to give me negative 18. Okay. So now I've simplified the right side. Now what I'm going to try to do is get my variable terms. Notice I have variable terms on both sides, so I want to get those to one side, and I want to always try to move the smaller one, but here they're exactly the same. And so that's kind of a clue. When the variable terms are exactly the same, when we go to get rid of them, they're all going to drop out. And so that is our case here, whether we're going to have infinite solutions or no solutions. Let's take a look at what we have left. Well, the 16x's drop out on both sides, and I am left with a true statement. Negative 18 equals negative 18. When the variables drop out and I have a true statement, that means I have an identity. Both sides of this equation were the same, which means all numbers are going to work. So we would have infinite solutions here in this case. Another answer that would have been acceptable for this would have been all real solutions. Now, very similar equation to this, variable terms drop out, and had I been left with an untrue statement here, like negative 18 equals 10 or something like that, that is a case where I have no solution to the equations. So one of those two cases, when the variables drop out, true statement, infinite solutions. Other case, variables drop out, and I have an untrue statement, no solutions. So make sure you look for those on the test. Okay, question 14. Again, I'm trying to solve this equation, but here I have a lot of fractions. And so what I want to do when I have fractions in my equation is just clear them out by using the LCD method. And so the first step is to take a look at the denominators and figure out what the least common denominator is of all of these fractions. So it looks like I have 2, a 3, and a 4. Well, if I found the least common denominator of 2, 3, and 4, that's going to be 12. So step 1 is to find that LCD. Now, normally when we find an LCD, we'd be trying to find a common denominator and make all these fractions have that common denominator. But when we're solving an equation, what we want to do is just multiply by that LCD, and that is going to clear all of these fractions out. So let's see, I'm going to multiply both sides by 12 over 1. Okay, and I got to make sure now when I'm multiplying, I multiply every single term by 12 over 1. So times the first term there, that's going to give me 12x over 2. Because in the denominator I have 1 times 2, and now times the second term, that's going to give me then minus 24 over 3. And now going across the equal sign, 12 times 3x would give me 36x. And in the denominator, just 4. And then finally, 12 times 1 will give me 12 over 2. Okay, so I went through, multiplied by this LCD. Now when I go to simplify all of these fractions, they're all going to drop out. Let's take a look. 12x divided by 2, that division works evenly. 12x divided by 2 is just 6x. And then 24 divided by 3 is 8. 36x divided by 4 would give me 9x. And then finally 12 divided by 2 would give me 6. Okay, now I have a regular equation without any fractions. Now it should be pretty easy to solve. Variable terms on both sides, so I'll move the smaller one. Let's see, negative 8 is equal to 3x plus 6. Okay, subtract 6. 3x is equal to negative 8 minus 6 will give me negative 14. Divide by 3. Next question we'll take a look at is question 18. Here we're asked to solve a literal equation for b. So basically what I need to do is I need to isolate or get rid of this, isolate this b, get rid of everything else, and get b all by itself. Well, you'll notice I have an equation with a fraction. And so anytime we have an equation with a fraction, let's go ahead and use the LCD method to clear out all the fractions. So here I just have one denominator, and that's 5. So I'm just going to multiply both sides of this equation by 5, and that will clear out that denominator of 5. So let's see, on the left side I just have this 5 times a. On the right side, I'm going to want to write, I'm multiplying all of this stuff, I want to write that 5 as 5 over 1 since I'm multiplying by a fraction. Okay, let's take a look. On that right side, notice I have a numerator and denominator of 5. Those are common factors. Those are going to divide out. And that was the whole reason for multiplying by 5 to begin with. So now I'm left with this. 5a, which was 5 times a. And on the right side, all I have now is b minus c. That's great now because I just one last step to get b all by itself. I just got to get rid of this subtraction of c. So I would just add c to both sides. And let's see. So b is isolated now, and then on the left side I'm going to have 5a plus c. And so since I've isolated b, I've essentially solved for it. So there's my solution. Okay. Next question, we'll take a look at our inequalities. So solve each inequality, draw a number line graph of the solution, and write that solution in interval notation. So in question 21 here, first thing I have to do is solve the inequality, which means I need to get x all by itself. So we solve this just like we would an equation. So I'd minus 3 from each side. Now we solve exactly the same way in every way that we solve an equation and an inequality, with one exception. And that exception is coming up right here. Anytime I multiply or divide both sides by a negative value, I need to flip that sign. And you'll notice to undo this multiplication by -2, I'm going to have to divide both sides by -2. Okay? So when we do that now, it was a less than sign, so I need to flip that sign and make it a greater than sign. This number on the right, 7 over -2, or -7 halves, we need to turn that to a mixed number so we can kind of get an idea what this will look like on the number line. So it's going to be a negative, and let's see, 2 goes into 7 3 times with 1 left over, so really that's just -3.5. So here is my solution statement. X is greater than -3 halves. So if we looked at that on the number line, let's say here's 0. Let's say right over here is -3.5, sorry. There's -3.5. X has to be larger than that. And we don't want to include this 3 halves or -3 halves as part of our solution. So we can do that with an open circle and values going to the right. We could do that with a parentheses. That means the same thing, that we're not going to include -3 halves as part of our solution set. So either of those graphs would have been fine. Now I want to write this, or kind of translate this graph now to interval notation. So kind of here what we do in interval notation, smaller on the left, bigger on the right. The smallest value that I'm going to approach is this -3 halves. Sorry, -3.5. The largest this value can be, it's going to go all the way off to the right, off to positive infinity. Okay? Now since I'm not including -3 halves, I put an open open parentheses around that. Infinity is not a real number, so we can't include it, so we always put a parentheses around infinity or negative infinity. And so there would be the solution represented in interval notation. Okay, question 24. Again, we're asked to solve this inequality. So let's see, a lot of stuff here to simplify. So on the left, I would start by distributing the 3. 3x plus 18 greater than or equal to. On the right, I would start by distributing the 5. So let's see, 5x plus 10 minus x. Okay. Right side can still be simplified a little bit. So let's see, we combine x minus 1x there. That would give us 4x. Okay. All right, now let's see, I got variable terms on both sides, so let's get rid of that smaller one. So let's see, then it would be 18 is greater than or equal to, let's see, x minus 10. Or sorry, x plus 10. x plus 10. Okay, so now just to isolate x, I just got to get rid of that addition of 10, so I'd subtract 10. Let's see, 8 then is greater than or equal to x. Now, we always want to read this from the perspective of the variable. Reading that 8 is greater than or equal to x is really going to be difficult to make our number line and our interval notation. But if we read it from right to left from perspective of the variable, which says x has to be less than or equal to 8, it makes it a lot easier. So we want values that are less than or equal to 8. So on our number line graph, the very largest this thing is going to be is 8. Less than or equal to, so we want to put either a solid dot or a bracket, and then we want x to be less than or equal to 8. So all the values now going off to the left on our number line. So let's see, headed this way, depending on how we graph this, either way would be fine. Okay, so there would be our number line graph, and now we kind of want to mirror this in our interval notation. The largest value that this thing could be would be a positive 8, and we want to include that, so I put a bracket around that. The smallest value this could be, well, that line's going to keep going off all the way to negative infinity. So the smallest value can be is negative infinity, and again, we always put a parentheses around positive infinity or negative infinity. All right, the next problems we'll take a look at are percent problems. We'll start with 26. 17 is 32% of what number? Well, anytime we're solving a percent problem, we're going to use our percent proportion to solve this. So P over 100 equals the amount over the base. And so the percent is always easy to find. It's the amount and base that get a little tricky. But the key here is that we're always taking a percent of this base. So whatever we're taking a percent of in the problem, that's always going to be our base. So let's go ahead now and fill this information from our problem 26 into this percent proportion. So our percent then is 32. So I'd say 32 over 100. And now I got to make sure I get the base next. So find the thing that we're taking the percent of. We're taking 32% of what number? That's what we're taking the percent of. So what number? That's going to be our base. We don't know, so we're going to leave that be. Okay? And then the other number in our problem, 17, that has to be our amount then. Once we find the base, we kind of get the amount for free. Okay? Now I just need to solve this proportion, so I would cross multiply. 32 times b would give us 32b. And that's going to equal this other diagonal, 17 times 100, which is just going to be 1700. Now I'm going to divide both sides by 32. So calculators are allowed on this test, so I just go ahead and do that division, punch that in. 1700 divided by 32 gives us 53.125. And since there was no indication of rounding, this decimal answer terminated. So that would be our answer there, 53.125. Had this decimal answer gone on forever, since they didn't specify, we could have rounded maybe to the tenths or hundredths place, and that would have been a good answer. Okay? Question 32. You purchase an item for $19.35 and get charged 8% tax on this item. What is the tax charged on this item? And then finally, what is our total cost? Well, okay, so we're going to use our generalized form here. So our percent in this case is 8%, so that would be 8 over 100. Well, again, we're always taking a percent of the base. Well, in this case, we're taking a percent of this amount charged, this $19.35. So that $19.35 is our base. And what we're trying to find out then is, after we take 8% of that, what is our final amount? And so there is our percent proportion. So we go ahead and cross multiply. Looks like I'll have 100A on one diagonal. And on the other diagonal, I'm going to have 8 times 19.35. So I punch that into my calculator. I get 154.8. Okay, divide both sides by 100. Divide by 100. Okay, dividing by 100, all that's going to do is move the decimal 2 places to the left. So it looks like our answer there is going to be this, 0.1548. Now, that answer is not appropriate for money because the smallest we go down to is a penny, so I'm going to run around to the nearest hundred or the nearest penny. So it looks like the tax we're going to get charged here is going to be $1.55. Okay, so we would want to now answer the story problem. We don't want to leave it A equals $1.55. We would want to answer the tax is $1.55. And then we'd also want to say the total. Let's make sure you use the same words, total cost, our total cost. And so all we have to do now is add that $1.55 to our original. So then our total cost we see is $20.90. So the next questions we'll take a look at are our word or story problems. So we're asked to set up and solve algebraically. Be sure to declare your variable and give a complete answer. Okay, question 37. A cell phone company charges $50 per month plus 10 cents per text message. How many text messages did you receive if the bill was $84.30? Okay, so what we're looking for here is how many text messages. So since that's our unknown, that's what we want to set our variable equal to. So I'd say, okay, x equals the number of texts we received this month. Okay, now we're ready to write our equation. And our equation is right here, that the cell phone company charges $50 per month plus 10 cents per text message. That's part of our equation. And then the other part of our equation is that we got charged this month $84.30. So there's the other side of our equation. And of course, in an equation, we want an equal side. I think the easiest side to write down is that this $84.30 was how much we got charged. Now the left side of our equation is just going to be right here. How do we figure out or come up with that charge? Well, it's $50 per month, so that's kind of a flat fee. So that's just straight up 50. And then we're going to add to that kind of this charge per text message, 10 cents per message. So if we wrote one message, it'd be 10 cents, or we received one message, it'd be 10 cents, 2, 20, 3, 30. You can see that we're multiplying. And so all we're doing is we're taking this 10 cents times the number of text messages to kind of come up with that total. Well, the number of text messages we decided was X. So if we just take 10 cents times X, that would give us the charge per text message. Okay, there's our equation. Now we're ready to solve. So I'd subtract 50 from each side. Let's see, then I'd have 0.10x is equal to 50. That's not 56, that was 50. 84 minus 50 is just going to be 34.30. And now I'm going to divide both sides by 10 cents. So let's see. 0.10x equals 34.30. Divide both sides by 0.10. Okay. So when we do that division, dividing by 0.10 is actually going to move the decimal to the right one spot. So it looks like we're going to get 343. And so then we would say, how many text messages did we send? We sent 343 text messages. Received. Okay. Question 39. Here, this is one of those story problems where we're just directly translating 3 times the sum of 4 and blah, blah, blah. So all we want to do now here in this type of problem is just kind of go through and translate each little phrase. So the first thing we're going to do is we're going to be taking 3 times the sum. Well, now the sum is more than one thing, so I want to write that in parentheses. So we're going to take 3 times this sum. And so I'm going to put the sum in the next part inside of these parentheses so that I'm taking 3 times this whole sum. Okay, now let's take a look. The sum of 4 and a number. That's what I'm taking the sum of. So that's what's going to go in my parentheses. So now let's read that back. 3 times the sum of 4 and a number, yep, that looks pretty good, is 30 more. 30 more then, well, here's how we take 30 more than something. We add 30 to it. 30 more than the number. Well, 30 more than the number, that's just going to be x. Okay, so there I've written my problem. Now I want to go ahead and distribute my 3. So I have 12 plus 3x equals 30 plus x. Okay, got variable terms on both sides, so I'd subtract x, so then I have 12 plus 2x equals 30, and now I want to subtract 12 from both sides. Let's come over here to finish. So then I have 2x equals 30 minus 12. Let's see, that'd be 2018. Okay, divide by 2. Okay, and now we want to answer the question. Find the number was what we were asked, so we would just say 9 is the number. I noticed one thing that I forgot to do when I was solving this problem is I didn't declare my variable at the beginning, so I'll come back over here on the left and say, oh yeah, in this problem we're going to let x equal the number. So make sure we put that at the beginning as well. And we'll circle our answer there. Okay, next question we'll take a look at is 41. And again, same instructions, set up and solve algebraically. Be sure to declare your variable and give a complete answer. So let's take a look at 41 and figure out what our unknown is. The drug concentration of C-chlor is 375 milligrams per 5 milliliters. How many milliliters should be administered to give an adult patient a 300 milligram dose of this C-chlor? So notice here is our question. How many milliliters should be administered? So that's what we want to set our variable equal. So let's let x equal the number for an adult patient here. Let's not write that just right. Okay. Okay. Now let's kind of go back and look at this problem. So the drug concentration, they're giving us this known rate right here, 375 milligrams per 5 milliliters. Anytime we see a given rate like that, like something per something else, we should kind of investigate to see if this problem is going to be set up as a proportion. And so if we read on here, they give us this known rate, 375 is to 5 millimeters, as 300 milligrams would be to, in this case, X number of milliliters. So this is definitely a proportion. And so we want to set it up that way. So the given rate, or in this case, yep, the given rate right here, is that in this drug, there are 375 milligrams of active drug in 5 milliliters of solution. So when you give a drug, the whole solution is an all drug. So in this particular thing, C-chlor, in this solution, in 5 milliliters, there are just the actual part that's drug is this 375 milligrams. So that's our known rate, and now we are going to set that equal to what we want to know. Well, we don't know how many milliliters to give, but we do know that we want to give this adult patient 300 milligrams of actual medication, and we're kind of now looking for X milliliters. Okay, now we have a proportion set up. Now we can go ahead and solve this. So let's see, on this diagonal I take 375 times x, which is just 375x. On the other one I'm going to take 5 times 300. So 5 times 300, that's 1500. Okay, now I have a simple equation where I'll just divide both sides by 375. Okay, let's kind of come up here. So then x is going to be 1500 divided by 375. Okay, so when we do that division, we actually get 4. And so that's milliliters. So we would want to now answer the question, how many milliliters should we give this adult patient? So we could say we should give 4 milliliters of this drug, C-chlor.